Hey, can you hear me? Can you hear me? Can you hear me? Okay, great. How's the clarity? Is it good? Okay, so this is the internet connection. Okay, yeah, video is fine. Okay, so let's see. We have Corbin, Jesse, Rawa, Muhammad Al-Qadi. We have Manny. We have Abdullah Al-Ghamdi. That's good. So let's get started. For those who are already watching the live, let's look at the virtual machine. So make sure that you start your virtual machine and restore the project. Okay. All right. So I just restore the project, and this is your source code. Design zero. This is going to be the basis for today's topic. Okay. So please do that. Okay. We have Mahama, Haji, and Christian. All right. Towards the end of the lecture today, we are going to try the remote support. So you look at the link I sent you, not the link, the instructions I give you on ULearn. We're going to use the Chrome remote support. So what it will do is you will create a password. You have to create a password and give it to me. Then I can use that to look at your screen and give you help during the lecture if anything goes wrong. Understand? Okay, now do not copy and paste the password in the live chat. If you do that, everybody can see it. Okay, when time is there, we are going to email you to email me your password so that only I can have it. Then I can use that to double check, make sure that I can get into your computer and then see your screen and then give you the support. Okay, any questions? Okay, no questions, let's start. So this is what we have for D0. Okay. Okay, so 1 second. All right, so get back to this. So this is D1, sorry, D0, and I assume that you're making good progress on D1. Am I correct? Okay. Now, if you look at D0, what we learned was a basic element of VHDL. You need to have a library, entity, and architecture in your code. You cannot miss one of these. This is the bare minimum of the VHDL code. Okay. Library specify what kind of library you're going to use for the project. In this case, we're going to use the IEEE library in 3 different packages inside the library. The entity is the circuit name that you want to build. In the entity, we specified inputs in alphabetical order by convention, output by alphabetical order by convention. Then the architecture specify what's going on or the operation of the circuit. What we did in D0 was to specify the Boolean equation of the circuit. If you go to ULearn, if you look at the handout, I gave you a truth table. And then from the truth table contained the Boolean equation. However, most of the time, you don't have the Boolean equation given to you. Then you need to derive the Boolean equation yourself, just like in D1. So for D1, you need to specify the Boolean equations based on the truth table. Okay, so this is D0. So you get the OR, the AND, the exclusive OR for each operation. LED2, LED1, LED0. Alright, now for D1, you don't have the equation. So in this case, what you do, you need to figure out the equations for these 4 outputs based on the behavior. That's what you need to do for D1. And today, we're going to talk about a new way or different way of specifying your circuits. Okay, so for those who came in late, no problem. Make sure that you restore your project design 0. This is the basis for our project today. Okay, and this particular topics that we covered today is going to be for D2. All right, so let me check. We have Aaron, Ibrahim, Urban, Christian, Muhammad Haji, Abdullah Gandhi, Nemi, Jesse, Rawa, Muhammad Akabi. Is Van here? What about Douglas? Van, Douglas? No? How about William? Is William here? Is William here? Okay. Alright, let's continue. Now look at this line, three lines. Line number 27 and line number 28. These are the equations for your circuit. Okay. So let's comment them out. Yes, Muhammad Haji, I got you. Today we are going to learn how to describe the truth table. So looking at D0, you specify the equations because these are the actions you need to accomplish. However, you can also describe the truth table of your circuit. Okay, so now we're going to describe the truth table completely. These are figure out the equations. But for D1, you need to put down the equations. But for D2, you need to specify the truth table. Okay? Now, when you specify the truth table, the process is more abstract, meaning that you don't need to know the logic. What you need to do is you need to make sure that you put down all the entries for the truth table. Okay? In this case, we are going to use keywords that's similar to C programming. Okay? First, you need to have the keyword process, and then begin, and then end process. Okay? All right. So for those who cannot see my screen, so this is the code that you need. Okay? Very simple. Process, begin, end process. Okay? So here, the thing I can do is I can make the fonts like a boldface. So it's visually it's more up, like visually it's better to look at. Okay. All right. So what is a process? A process is a circuit behavior, okay, inside the architecture. You can have as many processes as you can, and each process is independent from the other one. What I mean is, if you have two processes in your architecture, both processes will run in parallel. Okay? If you have 1,000 processes, you can have 1,000 processes running in parallel. Okay? This is very unique because in C programming, you cannot do this. Whatever you type in first will get executed first, but the processes will execute at the same time. Okay? But there's a problem. As the process is getting more and more, the circuit will get more and more complicated. And it takes a lot of time to actually figure out what to do. The software takes time to figure out what to do with these processes. So one thing we need to do is we need to tell the software, okay, when do you want to evaluate this process, or when you want to trigger this process to run. Okay? And you specify those in these parentheses here. Right now, if you look at this, this means that I have a process. It doesn't start running because you don't tell the program. Okay? All right. So in the parentheses, what you need to do is you need to type in anything that will cause this process to run. Okay? Very simple. Any input that you want to force the process to run, you put it here. Now, if you look at our example, we only have one process, which is the truth table. And the truth table has only two inputs, key 1 key 1 comma key 0. So what does this mean? This means that every time there's something happen to key 1 or key 0, this process will run. All right. So have we typed in the code? Well, you have to take this out because you don't want to describe the truth table and the equation at the same time. I'm commenting this out just to let you know that this is what we started with. Make sure that they are commented out. They are in green. Okay? Okay, so have we finished typing? Okay, so now we have a process. This process will run if anything happens to key 0 and key 1. Okay, anything happens, whether it changes from 1 to 0 or 0 to 1, you will trigger this process. Then begin end means that begin is the beginning of the operation inside the process. End means the end of this process. Okay. So going back to the truth table, so now we have non-press, 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 press, press, non-press, press, press. 4 different combinations. Okay. All right. And the truth table is OR. So what we can do is we're going to use C language type keyword. If key 1 is equal to 1, or key 0 is equal to 1, then LED2 is equal to 1. Okay? You say, how do I know 1 or 0? Very easy. Your goal is to describe logic OR. The definition of logic OR is if either input is equal to 1, output is equal to 1. Okay? Okay. So if T1 is equal to 1 or T0 is equal to 1, then output equal to 1. So what happens if they're not equal to 1? Else, LED2 is equal to 0. And if uh, right. So are we good with LED2? Okay. Is Douglas here? Is William Mendes here? Okay. All right. Yes, Ben, I got you. Yes. All right. So this is how you describe the OR. So look at this. The next operation is the AND. Okay. So let's do the AND. If T1 is equal to 1 and T0 is equal to 1, then output is equal to 1. Else, LED1 is equal to 0. So this is how to describe the AND operation. If both inputs are 1, output is equal to 1. Else, output equals 0. Now, if you remember from C programming, you can do if else, you can do if else if. So nested if else if. That's also possible. When you truth table, it's getting more and more complicated. You may want to use the if else if structure. Okay? But since in this case our truth table is very simple, that means there's no need to use the if else if structure. Okay? So please type in this piece of code to describe the AND operation. Now the last one is the exclusive OR operation. So I would like you to try first, then I'll show you the solution. Okay? So for those who finish typing the AND, you can try to create the truth table for the exclusive OR on your own. Okay, when you have finished typing both the AND and the exclusive OR, let me know. Okay, that's good. So for the AND, it's like this. For the exclusive OR, it's very interesting because if you look at the truth table for exclusive OR, it is not AND, it's not OR. It is if key 1 is equal to 1 and key 0 is equal to 1, it's equal to 0. Look at the truth table. See that exclusive OR? Okay. Else, if key 1 is equal to 0 and key 0 is equal to 0, then LED 0 is equal to 0. Okay. Else, LED 0 is equal to 0. So condition number 1, if they're both equal to 1, it is equal to 0. Okay. Okay. And if they're both equal to 0, it is equal to 0. Okay. Else is equal to 1. So this is exclusive OR. Okay. Now when you program the truth table in VHDL, you do not use the keyword exclusive OR, because exclusive OR means gate, means equations. It doesn't mean truth table, because in truth table, if you look at the truth table, there's no exclusive OR. It's only the AND OR operations. Okay? Now, if you look at this truth table, right? This is a typical if, else, if, or nested if, else, if structure, just like C program. Okay? When you use else, if, else in VHDL, you can combine the else, if into one keyword, and this is very unique to VHDL. You don't have that in other languages. Okay? Else, if is a nested structure, but else, if is not a nested structure. Okay? Like this. Now pay attention to the keyword. It is else, if without the extra E. Okay? So let me format this better for you so you can see carefully. Okay? Alright. So if they're both equal to 1, it's equal to 0. Else if they're both equal to 0, it's equal to 0. Else equal to 1. So this is an exclusive OR operation. Understand? So please type this in. This is exclusive OR truth table. Okay? Alright. Remember in VHDL, every time you want to terminate a line, you use the semicolon. This whole thing is only one line, even though it is presented to you in 2 lines. Understand? Okay. So if you look at the way it is now, it it is presented to you in 2 lines, but if you do something like this, it is equivalent of 1 line because there's no semicolon. There's only one semicolon. So a lot of time, people will retype or reformat the code like this, okay? Which is the same thing as before when we have multiple lines. Okay? So this means 1 1 equals to 0, 0 0 equals to 0, and 0 1 or 1 0 equals to 1, which is exclusive 1. Okay. Alright. So now you have seen how to use the if, else if, or the nested if else if structure. Okay. So let's do a file, save project. And then we're going to compile the code to make sure that there's no syntax error. So processing, start compilation. Okay, no syntax error, great. Now we don't need to change the pins because this is our old project. We have already assigned the pins. Okay, there's no need to do that again. Okay, so the next step is to do the simulation. Okay, so tools, run gate level simulation. Okay. Now, some of you came in late today. Uh, Probably missed the beginning of the announcement. When we finish the material today, we're going to try the Chrome support. So each student will generate their own password in their own machines and email it to me. Okay, and this password is not a one-time, it's not a permanent, it's one time. So every time you want to get a support, you better generate that. Okay. So the purpose of this today is to make sure that if something goes wrong during our live, I can go into your machine and look at your screen and then give you the help. Okay. Now, if you have errors, probably you're missing semicolons somewhere. So make sure that you pay attention to the semicolons and then the arrows for the assignments. Okay. So this is the complete code that we added today. Okay. Yeah. If you have errors, fix it. Okay. For those who have no errors, you should look at the screen. This is the Modelsim terminal and then the waveform screen. We're going to do that in a moment when everybody is ready. Yeah, you warn no warnings. I think you're good. Okay, so are we all set, everyone? Tools, run. Yeah, to open up a tool, you need to first compile a project. Then you can go to Tools, Run, Simulation Tool, Gate Level Simulation. Okay, right. So at this point, I assume most of you have fixed the errors, and this is the screen. Okay, right. So now we're going to run the simulations. So simulate, start simulations, and then let's pick the right thing. So you look at this, and the gate work is our design 0. Resolution nanoseconds. Okay, now you are in the simulation mode. So last class we talked about using commands to run simulations. Okay, and then we have used a few commands. And if you look at these are the commands we used. First two lines, we add the inputs to the waveform. Now you can use blue, you can use green, you can use red. So last time we used blue, so this time let's try a different color. Okay. So in this case, we are going to uh, use the orange for today's color for the inputs. All right. All right. So we're going to copy and paste into the terminal. And then here your color. And I can see that the orange color is not that sharp. I'll do the same thing for the outputs. Copy and paste. And green is very sharp. And now you don't want to use the same color for the inputs and the outputs. You want to use different colors. And then we apply the ones and zeros to the inputs. Copy and paste. And then at last, we'll run the simulation for 3 microseconds or 4 microseconds. So in this case, we have 4 different combinations: 0, 1, 0, 1, 0, 0, 1, 1. So this is going to be 4 microseconds. Okay. Alright. So let's paste. everything. All right. Okay. So let's look at the waveform. LED 0, 1, 1, 1, 0, which is exclusive OR. LED 1 is 0, 0, 0, 1, which is AND. LED 2 is 0, 1, 1, 1, which is OR. So this is exactly the same waveform we did last class. So changing from Boole equations to truth table does not change the circuit behavior because you're describing the same thing. However, if you look at the code, okay, if you look at the code, it is more readable because it's pretty much the C syntax. Okay, so in the industry, usually people write in this style instead of this style. Understand? However, in some cases, if you know exactly the equations, you write the equations. Okay. Okay. I don't understand what you mean by reading backward. Okay. If you look at the waveform, this is 0 0 combination, 1 0 1 combination, 1 0 combination, and 1 1 combination. That's how the truth table is structured. It doesn't matter. The goal is to get the waveform, make sure that it looks like this. Okay, the color, you can try different colors. Orange, you can see that it's good, but it's not that sharp. All right. So please go ahead, execute this command, and then make sure that you get the exact waveform as shown on the screen. I understand what it means. The transcript inputs are backward. This is the value you put in. So you're putting 0 first, then 1, then 0, then 1. And the time is 0, 1 micro, 2 micro, 3 microseconds. So going back to the waveform, this is 0 time, this is 1 microsecond, 2 microseconds, 3 microseconds. Time can only go forward, you cannot go back. Okay? So you specify the value in the order they appear. So I put down 0 first, then 1, then 0, and then 1. That's how they come out. Alright. So make sure that you type in these commands and run it, and then the screen will just fine. And let me know when you're done. We'll move on to the next topic. Yeah, you need to go back and check your code. If your code is different, of course, you will find those different. And also make sure that you're typing these commands correctly. It is 0, 1, 0, 1, 0, 0, 1, 1. If you use different values or inputs, your output will be different. No problem. You can keep your screen up when we do the remote screen sharing. I can help you to figure out why it doesn't work. Okay, no problem. So I guess everybody is ready. Well, most of you are ready. Right. So what I'm trying to show you is let's restart the simulation. Okay. In Modelsim, you don't really the Modelsim doesn't really care like uh, how you put in the commands. Okay. You can type in the command in the terminal, or you can just like me copy and paste. So a lot of time when we develop a simulation for circuits, we don't really need to type in commands one at a time. Okay. What we'll do is we'll create a command file like this, where you list the commands you want to have one at a time, okay? And then we are going to run everything at once. These are running individual ones. So we're going to copy. It doesn't matter how your truth table is presented. You need to cover all the combinations. The truth table can be upside down, left to right, it doesn't matter. You need to cover all the combinations in the truth table. Okay? The presentation of truth table is not a big deal. So coming back to the Modelsim, you create a Modelsim command file like this, where you list all the commands, and then you just execute everything at once. So let me delete this now. Copy everything at once, okay? And then enter. Here we go. This is your simulation. Okay? So the process is very straightforward. You type in all the commands in a separate text file, and we call this a command file. Then you just run everything from the beginning to the end. Now you don't do this one. This one is to restart the simulation. If you do it, you lose everything. So you just do this whole thing here. Copy and paste into the terminal, and then hit enter. It's going to run through every command. Okay, the sequence you type in. So now you're more efficient because you know you type in every single command one at a time. do it in a separate text file. Okay? For next assignment, starting the next assignment, you need to submit this command file. So this is just a text file to show me what command you use to run your simulation. So if I need to reproduce your simulation, I can use your command file and then run it. Understand? So can you confirm you understand what I just talked about in the command file? When you create a command file, what you do is you want to save it in the project folder. So you know that next time when you work on a project, there is a command file for you. Okay? When you archive these projects, these command files will not be part of it. So if you look at the instructions on ULAN, you need to submit the project archive, the VMP waveform, and the command file. So look at this handout here. For D2 archive, command file, simulation waveform in BMP, and then video of fully working design with design portraits safely in it. Okay? And this is a command file. I always save in the same project folder. Any questions? Yeah, I always use Notepad, just a text file. Okay, so let's summarize what we covered today. Today we covered in VHDL you can describe the truth table of circuits instead of the equations you derive from a circuit. Okay? So starting D2, you need to describe the truth table of the circuits. So if you look at a handout for D2, you need to use behavioral architecture and describe the truth table in VHDL. Okay? Now in D1, you're still describing the equations. Okay? And for D2 and beyond, you need to describe truth table and new methods. Okay? When we are going to learn more methods or more ways of describing a circuit. Okay? Then we need to look at the keyword we use in describing the truth table. So we use the if else structure, or you can use the if nested structure. If you see there's no need to do the nested structure, then you can combine the else if into one keyword, which is very unique in VHDL. Pay attention, there's no E here. There's no E between the S this case, this is no longer a nested if-else structure. This is going to be just regular if-else structure. Okay, now this structure does not exist in other languages. It only exists in VHDL. Okay. We'll also talk about you can present your truth table in multiple lines because in VHDL there's no concept of line. There's a concept of termination, which is the semicolon. So by putting in everything in one line like this, it is the same thing as putting in everything in two lines with a semicolon. Okay, so it's your preference to present this way or this way. Okay, totally up to you. Then we talk about in Modelsim, you can create a command file which has all the commands that you want to enter into the tool. And it's a text-based file, so I highly recommend you to use Notepad. Then, when you finish typing in everything, you can copy and paste all the commands and then paste it into the terminal of Modelsim and then run everything at once. So you start typing in one command at a time. So in this way, you are more efficient. Okay? Now, before you do that, you make sure that all the syntax are correct. Okay? If you have a syntax error, the tool will stop there. It will not execute anything out of it. Okay? All right. So D2 is already posted on Euler. You can start working on it. Okay? And also, uh, make sure that you read the textbook. Okay? So for this chapter, this is going to be chapter 1, 2, 3, 4 of the textbook. Okay? Now there's only 7 chapters we need to cover in this class. 1, 2, 3, 4, 5, 6, 7. Chapter 1 is the introduction of everything. Okay? All right. So make sure that you study the truth table and then write the corresponding code. All right. Okay. All right. So before we finish today, I would like to do right now is to make sure that we can set up the remote support screen sharing with your own computer. Okay. So please, D1 is due on Thursday. That's correct. D2 is due next Thursday. Okay. Please go to the Chrome remote desktop to generate a password and then email it to me. Okay. So when you start the Chrome remote desktop, there is a uh, remote support. There's a remote support option. If you click on it, you are going to see a password. It's a code, it's a number and letters. And give it email to me, then I can connect to your machine. This is a one-time password. So if you restart your machine, the password is going to be different next time you open the remote desktop. Okay? So whenever it's ready, please go ahead and do it, and then email me the password, and then I'll try to connect to your desktop to give you a remote support screen sharing. If that works, in the future, if you have any issues doing the live, I can help you. I can see your screen. Okay? So please go ahead and do it. Okay, so mainly we're all set. Okay, I'm working with Corbin, so give me a few minutes. Uh, Aaron, where's my movement of the mouse? Okay, yeah, as long as I can see your screen, we're good. Yeah, I can see your screen. All right, we're good. Okay, so Aaron, you're all set. Manny, you're all set. Kervin, I think you're all set. Anybody else? Anybody else need the screen sharing? Okay, yeah, Aaron, you can leave the chat if you would that. Okay, because I was able to get in and see your screen. Corbin, you may need to generate a new code for me, okay, so I can see your screen. And Ben, do you have a code for me so I can get in to help you? So Corbin, I'm in your computer now. I can see your screen, but I cannot click on anything. You see that? There's nothing I can click. I can only move your mouse. Okay. But anyway, I can see your screen. Can you move your mouse and make sure that I can see the code? Well, I can see your screen, but it doesn't matter. Can you scroll down to your code so I can see I can see everything? Because I can see that your code compiled properly. Yeah, because you were able to compile everything's green. And can you look at the Modelsim window? Show me your Modelsim window. Yeah, it looks the same, right? No, your D0 and D2 they look the same. Can you show me the commands you type in? Maybe you just type in the wrong command. Yeah, look at the commands that you type in. Okay, I can see that. Can you scroll up to line number 32? No, in the terminal. Let's look at the terminal. Yeah, scroll up to the terminal. Line number 32. Yeah, okay. So you have line number 33. Okay, that's good. Okay, your command looks fine. Okay, so let's look at the code. Your code looks fine. I think what you need to do is you need to get out from Modelsim and recompile this project and then do it again. I think that's what happened is probably your code and you make some changes, but you never, know, you were not simulating this code. You were simulating something that's before this. Okay, I think that's the reason. Okay, so I'm gonna get out. Stop. So anybody else for the screen sharing? Well, you need to install Chrome and then you need to install Chrome Remote Desktop. So I give you the name. You can just Google it, and then it will show you how to install the Chrome Remote Desktop. Okay. All right. So far I have taken care of Manny, Corbin, and Aaron. Anybody else? Okay, if you don't have anything else, I'm going to terminate the live in a couple of minutes. Okay. 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 No more questions. I'm going to terminate the live. You don't need to do anything to log in. You don't log into anything. You just need to create a password or access code and give it to me. Then I can log into your system. Okay. This is not going to be a one-time thing. We can try it again next time. Okay. So I'm going to terminate the live right now. Get ready for the next class. Okay. All right. I'll see you Thursday. Make sure that you complete D1. Submit the files before class starts on Thursday. Okay. All right. See you on Thursday.